Quick lesson on percent ionization. The percent ionization basically shows you to what extent an acid dissociates, whether 10% of it dissociates or 5% or 0.1% of it dissociates. And the way you can calculate it is you can take the hydronium ion concentration at equilibrium and divide that by the original acid concentration, not the equilibrium one, but the original acid concentration, and then times 100. So a way that might show up in a problem would be something like this. What is the percent ionization of a 0.125 molar acid whose Ka is 2.9 times 10 to the negative 10th? So they don't tell us what acid it is, so we're going to just use our generic HA formula and write a dissociation reaction. It's got a K, so it's going to be double arrows. It's going to make hydronium aqueous, and it's going to make the conjugate base aqueous. So we know that we started with 0.125. We know that we start with none of these, so we're going to lose X of this. We're going to make X of this and make X of that. So at equilibrium, our K value, 2.9 times 10 to the negative 10th, is going to equal our products divided by our original, or our equilibrium acid, X squared over 0.125 minus X. We're going to make the small x approximation, assume that this X is small enough that it's not going to change the 0.125 very much. So we're going to just avoid a quadratic that way. So now we're going to multiply both sides by 0.125 to get the x squared by itself. 0.125 times 2.9 times 10 to the negative 10th is 3.625 times 10 to the negative 11th. And we're going to take the square root of that, 6.02 times 10 to the negative 6th. So x is 6.02 times 10 to the negative 6. So that is our x. What was x again, though? X was the hydronium concentration at equilibrium. So if we go back to our definition, the percent ionization is the hydronium ion concentration at equilibrium divided by the original acid concentration. And now we have both of those numbers. So the number we just came up with, 6.02 times 10 to the negative 6th, that is our hydronium ion concentration. The original acid concentration was the 0.125. Then divide those times 100. And we get a really small answer, 4.8 times 10 to the negative 3rd percent. So something like 0.005% ionization. So that's a very small number, which we actually should have expected because that is a very small Ka value, 10 to the negative 10th. So that's how percent ionization works.